Welcome back, and today we are going to try to do a little bit of restoration work on this Hot Vac. This is manufactured by Ungar, model 4000. So I think I used this thing in like one video before, and unfortunately at the moment it's pretty much out of commission. There's a few things we're going to have to replace on it because it's got a few problems. The unit powers up and everything, and the vacuum does work, but the nozzle is clogged, so I got to clean it out. I'm going to have to take all this apart. But while I'm at it, I'm also going to replace this hose. As you can see, it I think it's got a little melty right here. I think I must have accidentally laid it down on top of my other soldering iron. The wires right here that run on in this cable, they're not damaged like all the way through. It's just the plastic sheathing has kind of gotten melted there. So I'm just going to kind of trim that back a little bit, make it nice and smooth. But the tubing's got to go. There's also this filter that fits in line with the vacuum hose. And this filter looks it's pretty nasty inside, and so that's gonna go. As you can see right now, there is no tip on this thing, but I do have the tip, and I actually managed to just recently pick up a couple of new ones. And the main reason why I want to get this working again is because it's gonna come in really handy for some of the videos that I've got planned. And while I can use like the solder sucker, the hand one, it's just easier to use this thing. And it's not the most reliable thing, unfortunately. It does kind of clog up at times, and you gotta clean it. But when it works well, it does a good job. And I mean, this thing is so old, and like, I doubt that this tubing has ever been replaced, and it's just like really nasty. So a couple of things I've done already is I've got me some new tubing. This is a 10-foot piece of 1/4-inch tubing. I was actually looking for, I snipped off a piece here. As you can see, this is the whole reason why this filter is not connected, because I cut this piece off so I can measure the tubing. It's about 1/4-inch, or it is a 1/4-inch outer diameter by like 1/8 inner diameter. But this is what I found at the local Lowe's here. So it's a 1/4-inch outer diameter, and it's 0.170 inner diameter, which means it's slightly bigger than an 1/8 inch. You can see how it's much wider. The only thing I worry about with this being slightly bigger is once the vacuum like hits, that this is going to kind of flex a little bit, inward, so it doesn't have like a strong wall to prevent it from kind of imploding on itself. And the other thing I did is I've got this cleanable filter. It's actually just a fuel filter, but you can clean the inside of it. You can open it up. And the funny thing is, on the listing it said it was designed for like a 3/6 inner diameter hose, but on the package here it actually says it's for a 1/4-inch inner diameter hose. Just a little minor discrepancy from what I thought I was ordering and what I got. The inline filter is basically mostly for keeping like debris from going into the pump. In the handle itself, if we remove this cap in the back, and right now I don't have anything in it, and actually you can't even see all the way across because the nozzle's clogged, so there's solder in there. But it would have like some cotton stuff back here, and then I'm probably not going to be able to see it then unless I move this light. But anyways, there's a little hole right there, and that's where the hose attaches to, or the tubing, and then this fits in the back. So basically when you suck solder, it comes all the way to the back. It would hit like the cotton stuff before it goes into that hole. But the inline filter is just to prevent any sort of little debris, because you are going to have to replace that cotton every once in a while. When you pull it out, you might have some debris that kind of falls into the hole. So that's what that prevents. So I guess first things first is we're going to have to open up the business end of the tool. That's not a big deal. It's just got these two screws. The one thing it is missing, it's supposed to have like a collar right here, but I never had that since I was given this thing a while ago. So, oh well, I mean, it still holds together. So inside, that's what we've got. It's like we've got a little bit of aluminum right here for just kind of shielding the heat from the handle. And here's the heating element. This is a little glass cylinder, and that's where all the solder ends up. You can see right there, that's where the hose attaches to, or the tube. So this is going to come off pretty easy. The only thing that really holds this glass to the heating element part, and then this rear exhaust, there we go. It's a couple of O-rings right there. So this just should be able to slide out like that. Yeah. So yeah, you can see all the solder right there. So I'm probably gonna have to take like a drill bit and just drill all that crap out of there. We're gonna give everything a really good cleaning. There's the button that you push to activate the vacuum. Oh yeah, and the other thing I want to do while I have this apart is if you can see right here, I've got this loom over the wire and the tubing, but it's really big. It's like way bigger than what you'd actually need for these two lines. I want to replace it with more like the braided material that you use for, like cables. and maybe that would make it look a little bit neater. And the whole reason why I even put that on is because, as you can see, there's like really like nothing holding these two together. I think it was supposed to have like a little tip cleaner right here or something, but I never had that. And I'm guessing this is probably for like a pick that you would kind of stick in the thing if it got clogged or something, but that's missing too. Or yeah, I'm not sure exactly what was supposed to go there. One thing I think I want to do is, instead of having the filter outside like this, is I'm thinking about maybe locating it inside of the unit. I just don't really like how it's sitting out here, and if I'm going to do that braiding, the wire cover, then I would want it to go, you know, like as far as it can, so like over here somewhere, and that way I don't have this in line. And I mean, it's not like it's hard to open this thing up to replace or clean the filter, so it shouldn't be that big of a deal either. And there's the inside of the unit. So back here, looks like that's where the triac is to control the heating element, because it is adjustable. You could turn it on here and then you adjust it, you know, to set your heat. It doesn't have any sort of feedback because it's not like there's a thermocouple or anything on the tip. Although it would be cool maybe to add one at some point, add some sort of you know, temperature control to this thing, because as it is, you basically, that's all you got. You know, you have your low setting over here, medium and high, so you know, you kind of set it somewhere in between there. But as far as the temperature, unless you're actually monitoring it with something on the tip, you really have no idea what temperature is actually going into the thing. There's the actual pump, and you can see it's a 115 volt pump, 60 hertz, 2.2 amps. It's made by Thomas, Sheboygan, Wisconsin. Looks like this is the inlet right there. Goes to that side, so I'm just gonna pop this out if I can without breaking anything. Oh, there it goes. Cool. Oh geez. Yeah, so this fitting right here is way bigger than the tubing was, so I'll just snip it right there just to make things easy. And now I should be able to just pull this out. Well, I really don't have much room to work right here. Okay, there he goes. All right, old hose, throw that away. So it looks like there's plenty of room right here to put the filter in somewhere, like, you know, just, it doesn't have to be like mounted to anything really, because it's not like this thing's going to be moving around anywhere. It's just going to be sitting stationary. I could have it come down here, so I have a little piece of hose like between these two, and then just have the hose kind of snake around the back and then out back out the front. And you can put this in right here. And this is going to be kind of hard to push on there because of the fact that it's meant for 1/4 inch inner diameter hose. But it's working. Ah, okay. All right, so that's on. I gotta push this onto here. And this went on a slightly easier, but see, this is what I was worried about right there. I got a little bit of a slightly kinked. Well, okay, maybe not. Maybe it's just because I was squeezing on it, but it's pretty nice and round, I think. So no, that might be all right. All right, that's a little bit cleaner now. So I can put this hose in from the front, bring it around. Holy crap. All right, it really does not need to go in all the way, but it's got plenty of tubing right there, so that's should hold fairly well. One thing I could do just to prevent this thing from rattling around like that too much when the pump is running is maybe put like a layer of foam around it, just kind of some foam tape. This cable could use a bit of a cleaning. It's pretty grimy and nasty, as you can see, so I'm going to give that a little bit of a wipe down too. Oh, that's gross. All right, we'll give it a second wipe down just to remove anything that might be remaining on that still. Slightly better, but might need a little more. Got a bit more out of it, but I think that's gonna have to do. It's fine. I mean, it's not like this thing's gonna be in a clean room or anything like that, so yeah, but at least it's cleaner. Help me sleep better at night. A lot of this solder like still has like flux on it, so, well, I mean, everything in here pretty much is coated with flux from removing parts and sucking solder and all that stuff, so the alcohol is doing a pretty good job of breaking it all down, so this is getting nice and clean now. There's still debris in this little nipple here, and I'm gonna have to get like a little pipe cleaner to clean that out. And there's little chunks coming out on the other side, so yeah, had quite a bit of stuff in there too. Oh, that looks much cleaner. Yeah, that looks much better. The reason why solder gets like stuck right here is because the heating element is like basically right up here in the front. So this area back here doesn't get very hot. So when the solder goes in, if it can't make it all the way to the back of where the little glass vessel is, then it kind of just stops here, and then it starts accumulating, and then it gunks up like that. And since I probably wasn't getting very good suction anyways because of that filter, like, you know, being clogged and all that, so yeah, it started accumulating right there, and that's what happened. So I'm gonna see if I can try to get this in there and clear up some of that solder there. There's some silicone right here, so I'm gonna try to be a little careful. Oh geez, look at how much there is in there. Alright, I think it made it through. Oh man. I'm going to try a slightly bigger diameter one and try to clear the rest of it out. Okay, this one fits in through the front, and it just barely fits, so I think it'll be fine. It actually stops right there. I think that's where it's starting to hit the solder. Yep, yeah, it's chewing in. Okay. And more solder. And now we'll go clean out the back here. Yeah, it's so clogged it like pushed the solder bits on the opposite end, but now that it should be fairly clear, try to flush it out with some alcohol. There's still debris in there because the alcohol's not exactly getting it out, but now I think I should be able to use the pipe cleaner and push it through, and hopefully this one should fit in there doubled over like that, because it is a wider hole. So, and it's having trouble going in, but okay, there it goes. It was just kind of stuck at the beginning. It's going in. It's going in. It's stuck. There we go. All right. Well, at least you can see through it now. Okay, I'm not exactly sure what this is all about right here, but there's this retainer that seems to be holding back a silicone gasket right there. Well, underneath this gasket, there's kind of a channel in there between the metal from the heating element and the gasket itself, and there was a bunch of solder that was kind of accumulated in there, and I was using this pick there to kind of just try to pull some of it out, and I got a lot of it out, but there still seems to be quite a bit in there, and I'm wondering if I remove that retainer, maybe I can just pull that O-ring out. Yeah, right there you see there's still more that I'm pulling out from inside of that, so there's still quite a bit of solder stuck in there, and I'm sure that's not helping things. So I'm gonna go ahead and see if I can pull this off, hopefully not damage that gasket in the process. Okay, so that retainer's out. There's the silicone ring gasket, whatever it is. See if we can pull this out now. Oh yeah, there it goes. There it goes. Okay. Oh yeah. Yeah, there's a ton of solder in there. Trying to get the good lighting here, but there we go. Oh geez. Okay. Yeah, we're just gonna clean that out. So I finally managed to get the inside of this thing completely clean, and in the process I kind of discovered a few things. One is that very inner tube right there is made out of ceramic, which is good because that means that the solder won't easily stick to it. And from those little cavities kind of on the opposite or on the sides of that inner tube, I pulled out this huge solder booger. It's like the kind of thing that you'd be like super satisfied to get out of your nostrils. And another thing I discovered, if we were to cut like a cross section of this heating element, and this is going to the tip, so this is the tube here, and this whole section here is what I've drawn here, is that right here we have that ceramic tube that's on the inside. This right there would be that red gasket that fits in the back with that retainer, so it fits in there like that, but it leaves a small gap between the end of that ceramic tube and the gasket, And this kind of answers a question that I had for the longest time, but I never really investigated. What I think is happening is that when you try to suck some solder, little bits and pieces kind of spatter and go into side of this little cavity here, and then they start getting stuck. And the problem is, because this isn't heated hot enough to melt the solder, it starts solidifying in these little cavities, and eventually it starts building up like a plaque of solder in there, and it just starts clogging it easier. I mean, the fact that this thing wasn't probably pulling like enough air as it was, you know, wasn't helping things, so it was easily able to just kind of get stuck in there. And so the problem I had was that I was using a 14 gauge piece of wire like this one, just solid copper. I used to use that to unclog the thing whenever it would get clogged back here, but I always wondered why I was only able to use like a 14 gauge piece of wire. So what happened is I would stick the wire in, and obviously because this is the heating element, it would heat up the copper hot enough that I could melt like a hole through the thing, but I wasn't completely unclogging the thing, so it was, you know, able to easily clog up. Like the next time I would suck solder, it may go through or it may not. So, but it was just really kind of frustrating. So what I decided to do is to try to make a silicone gasket that fits in this area here, so that instead of having this gap like that, we now have a basically like a solid pathway for the solder to go all the way through, so that it has no way of going inside of here and getting stuck. It should just, like, you know, like come out this way and into that little glass cylinder. I don't know if this gap that it has between this gasket and the ceramic tube was by design, or if it was kind of like a design oversight, or what. I don't know what functionality it would actually provide, but it seems like it's just more of a cause for headaches. And what I've got sitting here is attempt number 2 at trying to make a sort of a cylindrical gasket that I can use for that. I ended up having to get like some of this red RTV, like high temp gasket maker material, and this was attempt number 1 at trying to make a gasket. It didn't turn out very well, and it actually has a lot of air pockets in it, which are not going to be helpful at all. And so this was a kind of a failure. Kind of looks like a very small flesh. Let's see if this is going to work out a lot better. What I did is I actually put this in the vacuum chamber, and I sort of make this like paper hopper. I'm using a nylon kind of like a big spacer that has a diameter of about an inner diameter of about 3/8. So I'm hoping I can make like a small cylindrical gasket, and I'll just, you know, cut it to width once it's fully cured. And this is going to take a few days, unfortunately. I just finished vacuuming it out, so we're just going to set this aside and try to finish up the rest for now. I also ended up having to get more of this expandable sleeving, because I didn't have anything that was big enough, and this has an inner diameter of 3/4 inch, which should be just totally fine for the cable and the tube that have to go through it. I don't think there's any danger of this side fraying much, but just to prevent it from doing so, I am going to slide a piece of heat shrink over it. But just to prevent the heat shrink from sliding around, because there's really nothing to hold it, I'm going to use my favorite form of adhesion and put a little bit of hot glue over this part of the sleeving. And what that's going to do is, once I shrink the tubing over the sleeving, it should sort of adhere to both sides, and then that's going to prevent the heat shrink from sliding around. So there's that stuff applied, and here comes the heat shrink. Just gonna kind of let it overlap the sleeving a tiny bit, maybe about like 1/4 of an inch right there. And we just give it some shrink. I guess I should have waited to do the heat shrink here with the glue until I could verify that this tubing was going to... Oops, I almost dropped it on the floor, and that's glass. That would have broken. Alright. Whew. Anyways, yeah, I probably should have waited on this until I could have verified that this tubing is going to be adequate for this. Like I said, this one has a thinner wall than the original did. And one little problem that I kind of have with that is that this nipple that it's supposed to fit onto, it's very loose on, so that's not going to seal very well. However, I did come up with an idea for that, and that is to put this spring on the tubing. And what that does is it kind of compresses it a bit so that it's able to go onto that nipple there with no problems. So this here, I'm basically just going to slide onto the tubing. Alright, I think that's about as far as I'm going to be able to get there, but it's almost flush. It's just a tiny bit off. But it should be enough for this thing to be able to go on there, and yep, now it's definitely got some bite to it, so it's good. Yeah, that's not coming off. So I've been trying to figure out a way to make these gaskets that I want to use for the inside of the heating element. And this is the one that I showed the first time around. This is the whole little hopper thing. And this is the top cutoff. What I did is I actually trimmed this off and I filled it in with the silicone, hoping that maybe I can get sort of like the silicone ingot, and then I can just cut like a little slice out of it, punch out a hole, and use that as a gasket. But this was the original idea that I had, was to make a cylinder of gasket material right there, and then I put this pin in, which was coated with the silicone grease, so that I could slide it back out. But it seems to have stuck on there a little more than I wanted to, but I've already kind of gotten it loose here. Unfortunately, when I did pull it out, it seems to have brought some of the material with it, so I may have a little bit of pitting in that gasket material there, but I already sort of loosened it up here, and I can actually slide it out now. So that's basically like my blank right there, and hopefully if there's not like a lot of air gaps inside of it, once I slice off a piece, this would be like readily usable. So that's one. If this doesn't work out very well, I actually did a few other little sort of experiments here just to have some sort of a backup to like try out, you know, each if this doesn't work, you know, I don't want to be waiting days for another one to finish setting, because it's really thick, so it does take a while. But this one here hasn't completely solidified yet, because there's no way for the center in there to, like, you know, off gas or whatever. So I did try to peel it off, but it turns out that the center is still a little bit gooey, so this one would have to sit for a little while longer to fully cure. And then the other idea I came up with, which is probably the simplest and is probably going to be the one that works the best, it's just rolled up paper to the diameter of the original gasket. I mean, this needs to be a little bit smaller, but it doesn't matter because this stuff is flexible enough where I could just kind of stuff it in there and it'll probably hold anyway. But basically what I did with this one, same method that I used to fill that nylon spacer, is I stuck the end in there and I just filled it up until it, you know, started going in there. Once it was all kind of filled, I just stuck it onto a piece of paper again. Not this one, but you know, I just kind of stuck it on there so it formed like a nice flat bottom. So this might actually have formed a really nice blank that I can cut from. And then all I would have to do is just punch out a hole in the center for the material to go through. And the good thing about the paper is, since the paper, you know, is a little bit more porous than, say, this bushing or this spacer, is that the material can cure faster. So it feels like it's actually fairly solid. So I don't think there's going to be any problems with having like a squishy center or anything. I'm just going to open this up now. And this is the other thing that's a benefit to having the paper, is that it's easy to unroll from here. I'm just kind of gently peeling it so that I don't like tear it. I did coat the inside of this with silicone grease as well, but it doesn't seem to have done like that great of a job. It still sort of sticks, but it actually does peel off somewhat easily. The inside feels a little squishy still, but maybe if I could just cut off like a piece of the end there, it'll be fine. But I'm going to try this one first and see what this looks like. If this looks okay, then we might as well just stick with that. So this is a slice cut off of this blank that I made with the insert in the center to form the hole. And unfortunately, it does have some air gaps inside of it. So this is really not that great. Looks like this one's going to be the winner. It looks completely solid. And I mean, I have to use a really sharp blade to cut this because this stuff's not very easy to cut. But look at that, nice and mostly round, and absolutely no air bubbles or anything. And this feels nice and solid. So I'm going to punch out a hole in the center, and I think this is what we're going to use. And I took this piece of copper tubing and I just sort of reamed out the end a little bit to kind of enlarge it, and then I just sort of sanded it to try to make it kind of sharp. So I'm hoping this will work to punch a hole in the silicone. We're going to see if it works out as well as I hope it does. Yes, that worked out cool. That's going to be a nice gasket. Although I don't know, the hole might be a little small there. Let's see how it fits. Okay, I ended up having to trim it a little bit, and it's very difficult to trim this thing in any sort of, consistent way. So the sides there look a little flat, but the hole actually lines up like fairly well with the very inside of that ceramic tube. So now that I put this other one on, I should have a fairly good seal there going all the way across, so I shouldn't get any solder like getting stuck in that cavity anymore. It's not the best thing ever, but it's definitely an improvement from what it was. So I'm just going to finish reassembling this, and then we're going to take it for a test set. Gonna stuff some cotton in its booty. So these are the 3 tips I got. I've got this one that actually used to look like this one right here. These 2 are brand new. I just got these on eBay. And I mean, they don't make these anymore, so they are a little bit difficult to find, but you can find like some new old stock every now and then. And this one that I have here, actually, it didn't come with this. When I was given this, I was given it without a tip on it at all. But I managed to find this one at a local electronics store that was up where I used to live. Unfortunately, the tip that looked like that eventually kind of like broke off because, I mean, it was really, really like thin wall metal there. But it's okay because, I mean, this piece here is the one that holds the most heat anyways. And the hole diameter there was pretty good for a lot of like big diameter like pins on like, big components and stuff that I was trying to pull. But I did want to get like some smaller ones. That's why I got this little one here. And then this other one right there. So for now, I'm just going to try it with this larger one that I got and see how it works out now. I haven't finished the bottom part of this yet. I'm going to wait until see if it's actually going to work properly or not before I heat shrink it on. That way, if I decide that I'm going to have to remove this tubing, then I only have to undo the one side that I already heat shrunk and everything. I don't have to do both sides. So that's just going to stay like that for now. While I wait for this thing to heat up, I actually did find out what was supposed to go in here. I looked up some pictures of this model. It looks like it was supposed to be a tip holder. So when this thing was hot, it looked like it had like a ceramic insert sort of a thing right there. So you would actually stick this in there to hold it. And I thought it was weird how it had this other little hole right here with this metal clip that would hold the gun itself. But it looks like that was meant for storage, not for actually holding it when it was hot, because see, now this thing is all kind of like kind of burnt looking because it's gotten so hot. So yeah, it didn't really make sense to me to have this thing here to hold it when it was hot. But now that I've actually found out that it was supposed to have that thing here, well, that makes a little more sense. The only problem is finding something that actually fits in there to be able to hold it. I may have to end up making something, I don't know yet. But yeah, it's getting hot, so once it's warm enough, I'm going to try to pull this channel select switch off of this the 800 XL board and see how well that works out. All right, let's give it a whirl here. Okay, I didn't hold it long enough on that one. Oh yeah. Very nice. You can see the solder in there, how it went all the way to the back. So it's on that cotton now. Now let's try the smaller diameter tip and see how it cleans up some of these holes here where I removed the RAM on this board. Yeah. Oh man, I'm extremely happy with that. Nice. Well, that's working extremely well, so the only thing left to do is just to put this heat shrink here, pop it into there so it's nice and tidy, and all set to go. Just got to put the cover back on. Oh yeah, and one more thing. So it turns out this small board back here is not for the heating element. This small board is actually like as a solid state relay for the motor. The heating element actually has its own control up here in this area where this pot is. Turns out the entire thing here is basically kind of like a light dimmer. So that's just like adjusting how much current gets to the heating element the same way like a dimmer would with a light bulb. So I didn't touch any of that, and I mean, I kind of call this like a restoration, but I didn't take the pump or anything apart because I didn't want to have to worry about replacing any gaskets. And as you can see, the pump seems like it's working properly. It does pull quite a nice vacuum there. So I didn't want to touch any of that, didn't want to risk making it any worse. I mean, if it ever comes to the point where it's just not pulling anything at all, you know, maybe then I'll have to open it up. But for the time being, it seems like it's totally fine, so I'm not going to touch any of that. The potentiometer here, the control for the heater is seems to be working properly, so I'm not going to touch that. So yeah, seems pretty good. And there we are. So it looks much better, but more importantly, it works much better. I'm totally thrilled to actually be able to use this again because it's going to come in super handy. I was kind of getting tired of my little squeeze pump thing. It gets stuck sometimes, and sometimes like when you go to squeeze it down, the front end pops off, and then the like solder bits go everywhere, and it just makes a mess, and it's completely annoying. So to be able to have this thing be fully functional again is definitely a good thing. So once again, thanks guys for watching. I'll see you guys around the bench.